In this lesson, we're going to continue our study of the atom, and we're going to build up our knowledge so we're able to draw the atom in itself, the entirety, the nucleus, protons, electrons, neutrons, and the shells and orbits. So previously we've looked at the atom itself, and we should know how to find the number of protons, electrons, and neutrons in the atom from the periodic table. In this lesson, we'll advance this knowledge and we'll be able to complete our drawing. So as before, we can take an element on the periodic table. In this example, I've taken oxygen. Oxygen has an atomic number of 8, which gives you the number of protons. It also gives you the number of electrons, because the number of protons and electrons will always match. Protons being positive, electrons being negative, and the atom overall being neutral. Then we need to find the number of neutrons. So you take the atomic mass, which is the bottom number. This is 15.999. So we round that off to 16. The mass is made up of protons and neutrons. So we have 16 combined. We take away 8 protons, and that leaves us the number of neutrons, which is 8. Typically, they will be very, very close, if not identical. So here we have the nucleus with 1, 2, 3, 4, 5, 6, 7, 8 protons, and 1, 2, 3, 4, 5, 6, 7, 8 neutrons. So that's where we left it the last day. So we're going to build this on now and add in our electrons, which go in shells, also known as orbits and also known as energy levels. So that is what we need to have. We have our 3 names for things we can add. I'll typically call them shells or orbits. Energy levels is a bit more technically correct. So the electrons orbit or go around the nucleus just like planets go around the sun. The sun is the most massive, it has the most mass, just like the nucleus has the most mass in this system. So the electrons circle at particular distances and they go in particular shells or orbits. The shells, however, have a maximum capacity. There is a way to put them in. You can't just put them in any way you like. There is an order and a way that it must be done. So you can only have a certain number of electrons in each shell. As a quick tip, the noble gases all have full outer shells. So if you look at the noble gases, which we'll look at in the table in a second, they tell you how many electrons can go in each shell. But the numbers you need to remember are 2, 8, 8, and then 32, but we'll only ever go as far as the 20th element, so that would be 2 in this 4th shell. So the first shell can hold 2 electrons, the second shell can hold a maximum of 8 electrons, the third shell can hold a maximum of 8 electrons again, and the 4th shell then can hold 32. Now there's a reason for this. You study it more in advanced chemistry, but for now we'll just put them in like this: 2, 8, 8, and then the most we'll ever have is 2 again. So we'll not go beyond the first 20. Again, 2 plus 8 is 10, 10 plus 8 is 18, 18 plus 2 will bring us to 20, so that's the most we'll ever have. So the periodic table is here again. So what we want to focus on this time is the noble gases, this column here. So helium is number 2 because that first shell is full, so that can hold 2. Neon is 10, not 8, it's number 10 because this has an inside shell of 2 and then the second shell of 8, 2 plus 8 giving you 10. Argon then is the next one, so 10 up to 8, so this third shell, 1, 2, 3, the third shell can hold 8 again. And then kind of logically, if you were to go, the next shell you think would be 18. It's not quite, but it gets more complicated after that. So they are the numbers 2, 8, 8, and then for our study it's going to be the rest. We won't be worrying about these elements down here. So we'll take an example of this, and the example I've taken is to finish our drawing of oxygen. So I've drawn the oxygen down here, so this black line is the nucleus, and we have 1, 2, 3, 4, 5, 6, 7, 8 protons, then 16 minus 8, which gives 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. So we now need to add in our electrons. So the first thing we do is we draw in the shell. So there is the shell drawn in. So that is the shell in blue outside the nucleus. Be careful when you're drawing this. You have the nucleus, which is a circle, but the first shell is then the first line outside that. The first shell, if you can recall, can hold 2 electrons. So I'll put in my 2 electrons. They can go anywhere along. I typically go top and bottom. That is the most the first shell can hold. So now we need to draw in our second shell, and we always fill from the inside out. You'll always start with those inside electrons in the first shell. We draw in our next shell. This shell can hold 8, but again, if we check, oxygen only has 8. So we're already at 2, 3, 4, 5, 6, 7, 8. So that is our full electrons, that is our structure, and then just to show everybody what we have, we can write at the side 2, 6, because that is the numbers in the first shell and the second shell, which combine 2 plus 6 gives me 8. So that here is a full drawing of the atom. So that is how you draw the full atom of oxygen. Nucleus, protons and neutrons, and then in the shells or orbits or energy levels, we then have the electrons. 2 in the first, we only have 8 here, so we put in the other 6 into the second shell, and we can stop there. So we're going to continue here with the second example. In this example, we're going to go up the periodic table into one of the higher up elements and therefore one of the hardest. Potassium and then calcium, number 20, they're the two highest you'll have to ever draw. So potassium, K, atomic number of 19, so that's 19 protons and also 19 electrons. We then have to find the number of neutrons. So we look at the mass number here, it's 39.098. So that's 39.0, so we'll round that down to 39. So that's 39 protons plus neutrons, take away the protons, and we get the leftover neutrons. So here we have 19, 19, 20. Again, notice the three numbers are typically close, if not separated by 1 or identical. Never have 19 and then 39, that's too big of a gap, and you've done it wrong. So if we come down here, I've started the drawing of the atom. So we have the nucleus with the black, and I've got a bit lazy now at this stage because I should be well used to drawing dots. So I know that I should have 19 protons and 20 neutrons. I'll put the number in there instead of doing 19 and then 20 dots. Hard to do it accurately, hard to check that it's right. I've also here at the side in pink, I have 19. This is the number of electrons I need to put in. So I've drawn the first shell already, so that's the first shell, the first orbit outside the nucleus. So that's the nucleus, and then that's the first ring outside. So into this first shell, I can put 2 electrons. So I'll pop them in here, but that shell is now full. So because that shell is full, I can't put any more into it. So I have the 2 electrons drawn in. So I now have 17 electrons left to add. So that's 19 I need to put in total, and I've added 2, so that's 17 left to add, because I need 19 in total. 2 and 17 left. I need a second shell, and inside this shell I can fit 8. So that will be 1, 2, 3, 4, 5, 6, 7, 8 electrons. That shell is now full. So I have put in 8 into that shell, so I have now 9 left to add. I then have 9 left to add, so I need another shell. So I pop in this extra third shell. This shell can also hold 8, so I'll put in those dots. 1, 2, 3, 4, 5, 6, 7, 8. Keep my tally. I have taken out 8, so that's 1 electron left. All these shells are full, so I need another shell to put this into. So that's my extra shell, and that's my last electron. So that is the finished model of the atom. Scroll up here a little so you can see it in its entirety. So we have the nucleus with 19 protons, 20 neutrons. We have our first shell with 2, our second shell with 8, our third shell with 8, our fourth shell with 1. All of that adds up to 19. And then just to keep nice and easy, I'll write it as 2, 8, 8, 1. So that is my potassium atom number 19. You have to do this now for the first 20 elements. So I have oxygen done and now potassium done here, so you'll be able to copy those and use those as examples to help you do all of the rest. You need to put these into your copies. You may have the nucleus done already. If you can fit in the extra shells around those pictures, you don't need to do extra work. I did say as well when I was giving you the tasks that you should leave some space so you can fit in these extra shells. If you can't fit them in, just draw them out again. It's not that much work, and if you're doing it for a second time, you can do it like this, where you just put the number and P for protons and the number and N for neutrons. So do that, take a photograph of it, and then post it into the assignment. So when you are in the assignment, you should be able to click attach resource or add resource and then turn it in. Try not, if you can, to put in the posts, because then everybody can just copy your work, and it also means that you're not written down as having it done because you haven't got the assignment turned in. So best of luck with those and see how you get on.